Okay, so I already kind of wrote out a few things just to save a bit of time for this one. So in this question, we've got a plane, and the plane has a speed of 620 kilometers per hour, but we don't actually know the direction that it's pointing, right? We know its speed, and we know the direction that the plane wants to go, right? This is the desired direction, right? It's 35 degrees north of east. We want the plane to fly that way. But it tells us there's a wind blowing from the north. That's in this direction. And the question is asking, well, at what angle does the plane actually need to head in order to move in this desired direction? Because the plane is not actually going to be pointing along that line because of the wind from the north. So in order to sort of conceptualize this, I created a vector diagram. And I labeled it with some angles. So in this situation, this angle phi here, this is the desired angle that we want the plane to move at. Right? So that's 35 degrees north from east. Right? And if you look at this v net vector, that's the combined velocities of the plane and the wind together. Right? So this is the way the plane's actually going to move, and that's the angle that we actually want it to move at. Right, so we want the plane to be moving in this direction, including the wind. Now, we know the wind is blowing down, right? So we know that the plane's velocity, which we know the speed, but we don't know the direction, right? That's why we don't know this angle theta. Theta is actually what we're looking for. But we know that the sum of whatever that velocity vector of the plane is and the wind velocity vector should give us the net velocity that we desire. So the way that I thought about how to put this together was, well, we know that the sum of the plane and the wind's x components should equal the net velocity x component, and the sum of the plane and the wind velocity y components should equal the net velocity of y components. So if we look at this equation here, right, this v net cosine phi, this represents the x component of this v net vector. Right? And if we look at that vector, that x component of the net velocity, well, it all comes from the plane, because the plane doesn't have, or because the wind doesn't have any x component. Right? So the net velocity of the plane just comes from the plane's engine. It doesn't come from any wind. So the net velocity of the plane in the x direction is just v plane cosine theta. Right? Pretty straightforward. But in the y direction, right, the vertical direction, the plane's engine gives it some velocity. Right? So that's sort of vp sine theta. Right? So that's the vertical component of this vp vector. But the wind is opposing it. Right? So we have to subtract v wind. So this equation describes the motion in the y direction of the plane combined with the wind. Right? So this equation describes this is v net in the y direction, and this equation describes v net in the x direction. And the plane is actually, the question is actually asking for us to solve for this angle theta. Right? That's the angle that the plane is actually oriented at compared to the easterly direction. So we want to solve for theta, which means we're going to have to sort of put our equations into each other. So in order to do that, what I'm going to do is I'm first going to solve for, well, I think there's a couple ways we can do it. We don't know let's think about what we don't know. We don't know v net. Right? We don't know the magnitude of this vector. And we don't know theta. So what I'm going to do is I'm going to combine these equations to eliminate v net. So I'm going to take the first equation, I'm going to solve it for v net. So if I do that, I get v net equals vp cosine theta over cosine phi. And then I'm going to plug this into the other equation. So we get VP cosine theta over cosine phi. This equals VP sine theta minus VW. And now we need to solve for theta, which actually looks kind of hard. Oh man, hopefully I can do it. So if we want to solve for theta, we need to get all the terms with theta on one side.